Okay. All right. Good afternoon, everyone, and welcome to APNIC e-learning web class. We'll be doing best practice in managing internet resources. So when I'm saying best practice managing internet resources, so what we'll be discussing is what are the best current practices that we have to manage that internet resources in terms of IP address, both V4 and V6 and AS numbers. So when we deal with that addresses, the public addresses, obviously V4 and V6 and AS numbers, there are some do's and don'ts. There are something that you should do that you should not do, like to make sure things will work properly in a multi-stakeholder environment. All right, so yeah, that's what we'll be discussing today. So before that, we have a little bit of introduction about myself. My name is Nurul Islam Roman. I am currently the senior training specialist in APNIC. I'm in APNIC since 2006. Initially, I used to be the host master, deal with IP address and AS number requests from our members. But then I moved on to our learning and development team and looking after the technical training and development for APNIC. So as a professional, I have got interest on routing switching, MPLS, IPv6, DNS, DNSSEC, network resource management, or internet resource management, network securities, and so on. So we also have sort of an FAQ in our website, which is www.apnic.net/elearning support. When you'll be watching our web class, and if you're having any difficulties in terms of using our platform, you will can have a look on our website, and that can help you to solve some of the common problem. And end of the presentation, we'd expect you to spare some time to give us a feedback. So we'll be showing you the URL that you can use to give us feedback, and your feedback is very important for us to improve our future e-learning session. Okay, all right, let's move on. Internet resource management, and what is the objective? If you see the objective of internet resource management, there are three main objectives that we have. Number one is conservation. We need to conserve internet resources, since this is a public resource. So when we use that internet resources, we need to make sure that public internet resources we can conserve it, so that whoever need it, they can use it. The second goal that we have is aggregation, right? Aggregation is very important because the numbers that we deal with, right, if those need to manage in a service provider infrastructure, big infrastructure, and if you see on that IP core in tier 1, tier 2, the big ISPs, the size of that internet routing table is big, right? And if you don't do aggregation, it will be more big, right? So always we put some effort to make it short and sweet all the time. Okay. Then we have registration. So managing internet resource, we need to make sure we register internet resources. Registration is very important because this is how we will try to make sure which number is used by which users, right? And this is how, if there is any problem, any network error, any network problem, or any abuse or any spam happening, that can easily be identified and solved. So those are the main goal or objective that we have when we manage internet resources. Conservation and aggregation is sometimes like chicken and egg sort of things. Sometimes like when we need to conserve addresses, then probably we cannot aggregate, and sometimes when we need to aggregate, probably cannot conserve. So there is some sort of catch-22 issues in between conservation and aggregation. So that's why when we deal with IPv4 address, then we'll try to prioritize the conservation, because in IPv4 address, the address is running out soon, right? So conservation will get high preference in IPv4 address, then aggregation. But when it comes to IPv6 address, then definitely we'll prioritize aggregation first. Aggregation will get high preference, then afterward, probably at some point of time, we need to think about the conservation in v6. But in IPv6, so far, aggregation, aggregation, and aggregation. Because in IPv6, such a big number, if you don't aggregate, then on that infrastructure side, that can inject million, even billion prefixes into their global routing table size or global routing table. And that will be really unmanageable by the infrastructures operator. So aggregation is obviously will get high priority in v6. Then we'll have registration. Registration that ensure that uniqueness of the address, who is using that address, and the other address will be used by someone else. So registration will provide the uniqueness of that address, and also it will facilitate the troubleshooting, as I said. Okay, so those are the main goal of IP address management, both v4 and v6. Then afterward, we have uniqueness, fairness, and consistency. Uniqueness means when we distribute address, we need to make sure we give unique address to all those publicly available addresses. So same address cannot be duplicated with other host. Fairness, so when you distribute address, we have to be fair as well. So whoever need it, they need to justify in a fair ground. So based on that, we'll provide IPv6 or v4 address to the end users. Then consistency, right, in terms of your number of users. So it has to be consistent across everyone, how you distribute address. So as I said, so when you need address, because we need to kind of prioritize the conservation for IPv4 address, so that's why when v4 address will be distributed, we need to make sure those addresses will be effectively used, right? Whenever you need it, you can use, right? Or you can be delegated. And that obviously based on your demonstrated need. You need to demonstrate your address requirement. If you have 20 servers and you cannot ask for 200 IP address, based on the demonstrated need, from how many equipment you have, how many servers you have, how many sort of point-to-point link you have for the customers. So based on all demonstrated plan, you will be given addresses. That is why when hostmaster they evaluate your IP address request, they ask those sort of design documents, sometimes purchase invoices and all, so that they can justify your request based on your demonstrated need. Aggregation, as you all know, in IPv4, if you have full BGP feed, in IPv4 core routers, there are around 456,000 plus prefixes available. So 456,000 plus prefixes, that's a huge number of address that you have in your routing table, right? So yeah, so this is how we need to make sure when you distribute address, we can aggregate those addresses into your core routers. Then registration, as I said, when you'll be given, or any service provider will be given a prefix, a /20 or /22 nowadays, right? So APNIC, they will create a parent block for you on the whois server. So that is why, or that is how APNIC will make sure your parent block will be registered. Then afterward, from the parent block, when as a service provider, you will be further delegating address to your customer, right? So you can, or you need to register your customer prefixes. If you have end users like corporate users who are multi-home and get non-portable prefix from you on a /24 range or /23 or even /29, 28 range, that's your responsibility to register those individual customer assignment or sub-allocation into APNIC whois database. So when it comes to the customer registration, or customer block registration, any block which is greater than /30 using towards your customer network need to be registered, right, in APNIC with database. End users who are like using individual address, DSL or dial-up customers, right? So end users case, you can register an aggregated block. So for example, whole DSL or dial-up, you can register an aggregated. You don't need to register individual /32, just aggregated block for the dial-up port. That's how you can make sure you register it. And then afterward, definitely you keep the log of end users, like when the log, the authentication log. This is how you know which customer used which IP address at which days and times, right? So this is how it will facilitate the troubleshooting or any issue arise afterward. Sense? So IP address issues, as you know, IPv4 address exhaustion issues. So v4 address are running out soon. I mean, already it's gone in Asia Pacific. So if you see in IANA, the central registry, they don't have any address left to be distributed further. So they don't have any address left in IANA. But in the registry, regional registry side, APNIC has got some /8, LACNIC has got few /8, and ERIT has got few. But RIPE, which is European Internet and APNIC region, no IPv4 address left. So we have the final /8 that we are using very carefully, which is /22 per account in APNIC. And also the routing table, like as I said, in IPv4, there are 456,000 prefixes available. And if you see the origin AS of all those prefixes has been originated by around 46,000 AS, right? So on an average, each AS is announcing 10 prefixes, right, on an average. So that's we cannot do much. This is how we have to deal with. But the objective is all those big operators, if they try or if they can, they try to kind of aggregate the prefixes, and this is how we can reduce the growth of the routing table. And all those growth happen because of the tremendous growth of the internet, as you all know that. Then classful and classless. This concept is very much common sense to everyone now. When we operate internet early days, like 1991, 92, that time, all the routing protocol, they actually were doing routing based on the classful concept, class A, class B, and class C, and this is how address or prefix has been distributed at that time. But because of the address exhaustion crisis, right, so this concept, class A, class B, and class C, has been obsolete. So nowadays, no one uses it, and this is what the best practice. Don't use the classful concept anymore, just use classless. And classless, it can be /24, /23, /22, whatever the prefix that you can justify. And when you do routing interdomain, so you do CIDR or classless interdomain routing, and that allow the aggregation among the operators in the CIDR prefix range, which is /23, sometimes /19, sometimes /16, 17, depending on the prefix that you have. So those are the best practices, right? When you build or operate internet, so those are the best practices that you need to remember. If you see the APNIC distribution of IPv4 address from 1985, not APNIC from 85, the APNIC was not there at that time. So then APNIC distributed from 98 up until 2012, APNIC has distributed around 45, 46. It will be something around 53 number of /8 so far. That is what APNIC distributed up until 2012. Let's have a look on the growth of the routing table size. So if you see the very popular graph of Jeff Houston, our chief scientist. So on this graph, if you see, when there was no CIDR, right, there was no concept of CIDR. In 94, this time, the routing table tend to grow very high, very fast, right? So Since that time, there is no concept of CIDR and address management or address distribution. There is no standard, no policies, right? So then we saw routing table growth was exponential at that time. We saw a trend. Then we introduced CIDR at that time, and then effective distribution of address like registry systems and all. So this is how we sort of managed to reduce that, or managed to kind of restrict that exponential growth of the routing table, and it has been extended up until 1998. Then we saw the dot-com boom. During the dot-com boom, we saw the growth of the routing table as well in here. Then in 2001, we have the dot-com crash, right? After the crash, if you see the growth, which is a sustainable growth of the internet. So this is how internet is growing, right? And as you can see, now 450,000 plus prefixes that we have in the global routing table. This chart was developed or derived as of 6th of November 2012. If you see today, it's 450,000 plus prefixes that we have in IPv4. In IPv6, how the prefix is growing. In IPv6, if you see 2004, 2005, 2006, the growth was a bit linear. Then even after 2006 and 2007, the growth was down. And then afterward, after 2008, we saw there's a growth of IPv6 deployment. Then after 2011, we saw an exponential growth of IPv6 deployment. Why is that? Because in 2011, APNIC has run out all those addresses. Then afterward, we saw all the ISPs when APNIC doesn't have any IPv4. When we reached the final /8 actually, then ISPs, they start deploying IPv6. So now, as of now, if you see, we have around 10,000 plus prefixes in IPv6. Okay. Okay, there are some terminology that we used in the IP address management policies. The policies that we have in IP address management, both V4 and V6, there are some terminologies that we have is very, very important. One example is the allocation and assignment. So what is an allocation and what is an assignment? Allocation is a type of address distribution by the registry, right, to the service providers. So when the registry, they distribute address to a service provider, for example, an ISP or a telco who will provide internet services, right? They distribute, they will be given an allocation of a /24, /23, or /22, right? So allocation means this type of address, when it is given to a service provider can use that address in their own infrastructure when they have servers, routers, switches, for the management purpose. If they want to use it, they can use those prefixes or the addresses there. And then they'll also have their customer. So they can further give this address to their downstream customer as well, right? So when those addresses are given to the downstream customer, if the downstream customer is single home, simply they can be part of that ISP network. If they're multi-home, they need to announce their prefix individually from their router, right? So if it's an allocated block, that block can be used even for the customer network as well, right? If you have a customer. On the other side, we have assignment. So if any organization getting an address from APNIC, right, and if they are not a service provider, but they are an enterprise, and they are like a bank or university, right? They're not an internet service provider, but they are a banking service provider. But the internet is just a tools utility for them. So in that situation, registry or APNIC can give them an assigned block, right? When an assigned block was given to them or will be given to them, what they can do, they can use that block into their infrastructure for their own use, okay? But from the assigned block, they cannot further give it to their downstream customer, because the end users, so for example, a bank, they should not have any customer, right, in terms of the internet service. So they can use that prefixes into their own infrastructure, but they should not give it to their further downstream customer, right? So the reason behind that, this is how, by using the address management policy, we try to reduce the routing table growth. What are the prefixes? Are allocated prefix. So if that prefixes are further subnetted, right, and an individual prefix announcement is coming from an allocated block, upstream or tier 1, tier 2, they can allow transit for those individual specific match prefixes. But assigned block, when it given to that end users, if they further split it or subnetted and used specific announcement from that subnetted block, that should not be allowed as a transit. So this is what the purpose of it. And if you're clear about that policy of address management, and this is how, if you build your operational network filters, prefix filters, then it will help you or help the whole internet community to reduce the routing table size. Make sense? So this is the concept that we have for allocation and assignment. Portable, non-portable. What does that mean? It means, portable means when you have a portable block, right? Then when you change your upstream ISP, so today you are connected to Singtel or Telstra, so for example in Australia, and tomorrow if you move out to another operator, another ISP for your internet transit, right? And if you have a portable block, you can carry your prefix with you. Right? And then you don't need to renumber your network. Just announce the prefix of the new ISP. So that's what we call portable block. On the other hand, we have non-portable block. What is non-portable block? A non-portable block, you can get from your upstream ISP, right? And then build your own infrastructure. As long as you're connected to the same or that upstream ISP who gave you the non-portable block, you can use it. But when you move out to a new ISP, right? And with the new ISP, you cannot carry their address. You have to return that address back to the old ISP, and with the new ISP, you will receive a new block, right? And you need to renumber your whole network. If your network is big, right, and if it takes time to renumber it, then it's better to get a portable block instead of a non-portable block. And who can give you a portable block? Not your upstream. Only the registry can give you a portable block, like APNIC or ARIN, right, or RIPE-NCC or APNIC or LACNIC, right? So those the registry can give you portable block, right? So when we have more portable block, that will cause the growth of the routing table, right? So that is why portable block, to get a portable block or to become a member of a registry, you need to justify some qualification criteria. If you can justify, if you can pass those qualification criteria, then only you'll be given a portable block by the registry, and then you can build your own network, right? So this is what portability and non-portability. Okay, addressing plan. When you do the addressing plan, how you do it? So when you do the addressing plan, first of all, you need to identify the component of a network, right? If you see your network has got like two main components. Number one is the infrastructure, and number two is your customer. So those are the two main components of your network. So for the infrastructure, within the infrastructure, you have smaller component as well. The very first one is your loopback, right? All the routers loopback is your very first component. If you have 20, 200, 300 routers, so 300 loopback address that you need. And on loopback, the best practice is we give /128 in IPv6 and IPv4/32. Some places we saw people use /24 loopback, but that's very, very bad wastage of address. So for loopback, best prefix is /32 in IPv4 and in IPv6 /128. Then the next component that we have is our transport. If we have our transport network, like the regional networks are interconnected, for the transport, we can use any subnetted prefix. Like it could be /29, /30 sometimes, right? /48 in IPv6, /56. It depends on your network design. And then after that, we have our point-to-point link, right? In our network, we have a point-to-point link for the infrastructure and then point-to-point link towards the customer. So this is how we calculate how many point-to-point link we have within the infrastructure now, how many we are planning for next 1 year, 2 years growth, right? And then how many point-to-point link that we have towards our customer. So this is how we calculate all those point-to-point link. Then afterward, we calculate our data center components. So how many servers we have, right? So all those sort of, servers might need addresses. So this is how you calculate or identify the component into a network, right? And then when you do the deployment plan, so in a deployment plan, you should plan from today in 6 months time and in 12 months time. So this is how you calculate your address requirement in 12 months time, right? Then also, like, you need to kind of identify the growth. So for redundancy, for the scalability, like, how you are planning for scalability for next 1 year, 2 year. So this is how you calculate your address requirement in the addressing plan. Okay. So all the address space that you have should be documented. So as I said, all the address space that you have, say for example, your loopback prefix aggregated one, your transport prefix aggregated one, your point-to-point prefix for the infrastructure aggregated one, for the point-to-point prefix towards customer pop aggregated one, right? Those all you should document, right? Definitely you have documentation within your network, like, either an automated IP address management software or on an Excel file, right? But in terms of the registry system, you need to register those into the APNIC database as well, right? When you register those in APNIC database, this is how the registry knows your address utilization. And then when you need more address in future, registry knows how your address has been utilized, right? Otherwise, if you don't register, if you don't document, then you will have a hard time when you need more address in future, because according to the registry database, none of them are utilized because you haven't registered those, right? No reservation policy. In the registry system, we don't allow the reservation, we don't permit the reservation, because this is how the policy is. Reservation means, like, if you have a plan, if you had a plan before to deploy dial-up and now you don't have any plan, but you reserve address for that. No, if you don't do dial-up now, just use that address for your DSL purpose, which is the current deployment. In future, when you do it, let's consider that things at that time. Then you send another request and host master or APNIC host master will evaluate based on that current situation at that time. So reservation, which is not permitted according to the policy. Sub-allocation. So when you have got an allocation from the registry as a service provider or as an ISP, and when you further delegate that prefix towards your customer, that's what we call sub-allocation, right? So when you give address to your customer, if your customer is an end user, right, it will be an assignment. But if your customer is another small ISP, that's not an end user, right? So that's a sub-allocation. So if your customer is another small ISP, we call it sub-allocation. So for that sub-allocation, we have a process called second opinion process. So you need to send a second opinion process or second opinion request to the host masters. So host master, what they'll do, they'll just try to just help you in terms of your address distribution, like, the way you have justified to the host master, the same way you are asking justification from your customer as well when you give address to the customer. So that's why you have the second opinion policy. Second opinion, it depends on your assignment window. Initially, as a new member, your AW or assignment window will be 0. So when your assignment window is 0, then you cannot give any prefix to your downstream customer without a second opinion, or you should not give any prefix to your downstream customer without a second opinion request, which is greater than /30, starting from /30/29. So anything /29, you need to send a second opinion if your AW is 0. Then every 3 second opinion, if you do it properly and register those assignment in APNIC database, your AW will be increased to the next available, which is 0 to 8, then 8 to 16, 16 to 32. So this is how your AW will be increased, right? So when you send IP request for V6 or V4 to host master, make sure you send it for 1 year. Sometimes we saw some people they send address request to APNIC for each customer. So when a customer comes, they send a request. When next customer comes, they send another request. So that is probably not recommended. You send a request by calculating your 1 year requirement. So APNIC provide address every, instead of 1 year requirement framework. So you also do the same, just calculate your address requirement for next 1 year and request for an address. Sub-allocation guideline. So as I said, sub-allocation is something that is towards your downstream customer, and if your downstream customer is a small ISP, and if you're giving anything greater than /30 and if your AW is 0, you need to send a second opinion request. In sub-allocation, you ask why they need the address, and obviously you give CADR prefix, not classful addresses. And obviously now it's not possible because we don't have enough address now. And you also register those things in the APNIC quiz database. All the sub-allocation you should register into APNIC quiz database. Address assignment. When you assign address to your downstream customer, obviously it's based on the requirement. Obviously it's based on the requirement, and is on the demonstrated need. So when you do address assignment to your downstream customer, right, make sure your downstream customer they justify their address request to you. If they need a /29, if they need a /28, they outline the number of equipment they have, number of routers they have, number of servers they have, and based on that you give them the address. The justification is as it is when you need to justify to the host master for your address. So this is how you will justify, and when you will give address to your downstream customer, make sure you use variable and subnet marks. Don't just give /24 per customer. That's not good anyway. IPv6 address assignment, how you assign IPv6 address. As you can see from the APNIC guideline, IPv6 address end side, right, on the interface ID side, you can give /64, you can give /60, you can give /56, you can give /48, right, based on the demonstrated need. But normally in IPv6, in APNIC guideline, it is recommended to give /64, /56, or /48, right? So when your end site is you're 100% confirmed your end site will have only one link, one subnets, right? Then probably you can give a /64, because in IPv6 you cannot give any prefix less than /64 prefix size. So if you are 100% confirmed your end site, your customer will have only one link, then probably you can give a /64. But if your customer will have more than one link, then the next available is /56 could be, right? And if your customer is multi-homing, or end users like who are gold customer will be multi-homing, you can give them /48. That's the recommended, that's the best current practice. The reason behind that is when the vendors, they produce the CPE, in the CPE they use a very kind of strict prefix length. Sometimes they only support 64, 56, and 48. Sometimes some operators they only support /56 or /48 or /64, right? So depending on the standard. So that's why in the industry the standard is going towards 64, 56, and /48 on the CPU side, even the OS level as well. So probably it's better to plan 64, 56, or 48 prefix delegation towards the downstream customer in IPv6. Okay. AS numbers, autonomous system. What is an autonomous system? An autonomous system is a collection of routers under the same administrative control and under a single routing policy, right? So when you are building an AS to do your own BGP, you need an autonomous system number, right? So where you get the autonomous system number from? From the registry, like for example APNIC. So when you receive that autonomous system number, right, then you can build your own AS. And if you need to know more about how to build an AS and what are the guidelines policy wise, then RFC 1930 is the best document that talks about how we can build our own AS, in which situation we need our own AS number. Okay. So when you request an AS number, you can request the AS number on behalf of your customer, or you can request an AS number for yourself. If you request an AS number for yourself for your own use, that AS number will be portable. It means if you move out, move from your upstream to another upstream, you still can use it. Use the same AS number. That's why it is portable. So if you're requesting an AS number for you, that obviously be portable. You can ask or you can request an AS number even for your customer when your customer is not an APNIC member. If your customer is not an APNIC member, still you can request an AS number for that customer. And in that case, that AS number will be non-portable. What does that mean? It means when you move out, you have to, or your customer move out, right, and getting internet from different operators, they need to return that address back to you, and you need to return that to the registry, for example, APNIC. Transfer of AS number is also possible, right? So say for example, today your customer is not an APNIC member, you request an AS number on behalf of them, which is non-portable. But tomorrow if your customer become member of APNIC, then the same AS number can be transferred to that customer if both you and your customer agree. Okay. Or like, if two organizations they merge, AS number can be transferred from one account to other account. Make sense? Managing which database? Managing reverse DNS in the which database? What is the reverse DNS? For the infrastructure ARPA domain, .ARPA, when the whole /8 is given to APNIC, right? For the whole /8 ARPA domain, authorization is given to us APNIC name server for the whole /8. So when APNIC is allocating a part of it, a whole a /20 or /22 or /16 to APNIC member, right? Then from APNIC DNS server, a further delegation need to be created to us your name server for that /20 or /16, right, blocks. So whenever you receive a block from APNIC, that is the responsibility of the member, right, to ask APNIC to make the delegation for your smaller prefix. So when APNIC DNS server is authorized for the whole /8, then APNIC, if you ask, APNIC will make further delegations to us your name server for your specific smaller block, /20 could be. So if it is /20, then according to the IPv4 ARPA domain, how it works, you need to create 16 number of /24 prefix, ARPA delegation, and then you need to manage your own PTR record into your own DNS server. APNIC will not manage the PTR record or individual PTR record. APNIC will only maintain a glue towards your name server for your blocks that you are receiving from APNIC. Then you need to manage your own PTR record into your own name servers. Okay. So to manage all the resources, how you can manage it, what are the tools that we have? So APNIC has got a website called MayaPing. MayaPing is a very useful tool for APNIC members to manage the resources. So MayaPing can be used to manage your IP address assignment, AS number, reverse DNS delegation, your membership contract, membership renewal, payments, and everything, right? So that's the end of the presentation for today in terms of managing best practice to manage internet resources. So we have an URL here, so that URL can be used to kind of provide a feedback. So when you use that URL to give us a feedback, then that feedback, after the feedback, it will be redirecting you to an FTP site. From there you can download that presentation that we used today. Okay, so you can download the FTP. So now we are at the question and answer section. Do you have any question now? Is there any question? Okay. If there is no question, then thank you very much. I hope that session will be useful for all of you. And as you know, like APNIC runs this e-learning web class every Wednesday. Just keep your eye on to APNIC website www.apnic.net/training or training.apnic.net. Then you can see our future e-learning schedule. And if any of the topic that you feel like interesting to you, you can just register